Hi, in this project, I will show you how to use stepper motor proximity sensor with external interrupt with Arduino Uno. Before I move further into this project, let me explain and demonstrate how this project works. In the picture, you can see that I use proximity sensor connect with Arduino Uno on external interrupt pin. Every time I move this proximity sensor close to metal or magnet, it will activate interrupt in Arduino pin. Okay, and I put some code to make sure that every time I activate this proximity sensor, it will command step motor to move in uh, different direction or stop. Okay, the first one I activate, the motor move backward. Okay, and then I activate proximity sensor, the motor stop. Again, I activate, this time the motor move this direction, move forward. And then I activate again, the motor stop. And then I activate again, the motor move backward again. It will keep going on and on like this. So it means there are four states of the motor that can be run, right? Stop, move forward, stop, move backward. Okay, next I will show you to connect all equipment of this project together. In this project, I use bipolar stepper motor, which is have 200 steps and it work on 12-volt power supply. I have hybrid L298N, which is also require power supply 12 volt. I use Arduino Uno and I use proximity sensor. This is the code of this type of proximity sensor that I use. This proximity work on the power DC 6 to 26 voltage. And I have switch mode power supply that provide DC 12 volt and the current up to 4.2 amp. So the connection first, we have to connect the wire of stepper motor. Because this is a bipolar motor, it has four wires. We have to connect two wires together. In this one is a yellow and blue one. On this side of hybrid, and they connect another two wires, the green one and the red one on this side. And then we connect the pin 11, 10, 9, and 8 on the Arduino pin in this location. And we connect power supply to our switch mode power supply. Oh, be careful because of this motor might consume a lot of current. You have to make sure that you have big enough power supply that can provide enough current to drive motors. If you use bigger one, it need more power, more current. For the next one, how to connect proximity sensor. How to connect proximity sensor in order to read the value of proximity sensor. Okay, the proximity sensor, this one is connect to the power supply 12 volt from switch mode power supply. The color of the wire of the proximity sensor, let me show you. Okay, Normally, this type of proximity sensor have three wires. The color is brown, blue, and black. Okay. For the brown one, it connect to this one. I connect to 12-volt power supply, and the blue one connect to the ground, and the black one. This is the signal. The signal normally it will provide the voltage zero in normal condition. But whenever you activate proximity sensor by moving metal or magnet to close enough, it will activate, activate this proximity sensor, and it will give signal 5 voltage. But however, in order to make sure that our Arduino can read the signal properly, we need to connect pull down resistor to the cloud. In this case, I use trial and error, and I find out that I used 4,000 ohm resistor. Okay, before you use this one, you have to make sure by using multimeter to measure the signal here that come out when we activate. The signal should be around 5 voltage because our Arduino board can read 5 voltage as a high or as a one. Okay, if it's zero, like this one, it means zero voltage. Okay, come back to the total connection diagram. Okay, our proximity sensor, we connect the brown line to power supply 12 volt, and the blue one connect to the ground. Okay, and provide pull down resistor here, and we connect the signal wire on the black wire in this position and link directly to our external interrupt pin. In this case, for Arduino Uno, I use pin number 2. Okay. In order to maybe for the safety purpose, in order to make sure that the the signal, the power signal that go into our Arduino board is limited. So I provide 500 ohm resistor in order to make sure it limit the current that go to our Arduino board. Move to the next part is the coding of this project. In this project, we need to use library stepper to drive stepper motor. First, we have to declare the variable for step per revolution. In my case, I use the stepper motor bipolar type, which is have 200 steps per revolution. And then I define the variable for the object of stepper class and give parameter stepper per revolution, which is 200, and pin for Arduino Uno 8, 9, 10, and 11. These four pins will send signal to HBit driver, and then HBit driver will send the power signal to drive stepper motor. And then I define the variable spin as a boolean and see the build as a boolean as well. For the spin, if it is true, it means the motor will run, right? But if it is false, the motor stop. For see the build, if it is true, it means it rotates clockwise, and if it is false, it rotates counterclockwise. For volatiles, volatile is the recommendation from the Arduino to know that when we use this kind of variable inside ISR function that we use for interrupt, we should declare our variable as volatiles. I will talk this one a little bit more detail in the next part. For setup part, first we declare pin mode to be input for pin number 2, which is external interrupt pin. And then for the object my stepper, we set speed to be for 240 round per minute. So I use this number because I have tested many number. For me, I'm satisfied with this number 240. It runs quite smooth. And then for attach, and then we declare attach interrupt on pin number 2. And for the function that will be activated when interrupt happen is change state function. And the trigger mode is rising. For more detail, let me explain as following. For external interrupt pin in Arduino Uno and Arduino Mini, normally it provides pin 2 and pin 3 for interrupt. But for other models of Arduino, you can see that, for example, in Mega, it have six pins for interrupt, right? So it depends on your project. If you have the big project that require many pins for interrupt, so you need to select the proper Arduino board for your project. This is the code example code from Arduino.cc, right? To show you how to use interrupt, external interrupt. So as I mentioned before, right? Uh, every time you need to use variable inside your function in attach interrupt, you need to declare it as volatile. So in this case, it's declare variable state as volatile. In the setup part, it used the pin 13 as a pin mode for output, and for pin mode interrupt, it used as an input with pull up function. For this part to declare interrupt, you need to use the command attach interrupt, right? First parameter is you have to determine the pin that you will use for interrupt. In this case, is pin number 2. You use this command, digital pin to interrupt, pin number 2. And the function that need to be performed, that you want it to perform whenever interrupt happened. In this case, it use function name blink. The function blink is quite simple. It just change the state, right? From low to high, from high to low. Every time the interrupt is activated. And the last parameter is change. This is the mode that when interrupt happen, it can happen in many mode. Let me show you, right? For mode to trigger, mode low, it means the triggered whenever the pin is low, it means 0. For change, every time the signal change, right, at the pin, so from 0 to 1 or from 1 to 0, every time it change, it will trigger the interrupt. And for the risings mean that the trigger whenever pin from low to high or from 0 to 1. Falling, it means whenever the pin go from high to low or from 1 to 0, right? So in this example project, it use change. It means whenever the interrupt trigger signal happen, for example, from high to low or from low to high, it will activate this function. And then in the loop part, it will show you the signal from the LED at pin 13, right? So every time you activate it, right? So it will show, for example, the LED will turn on and then it activate, right? The LED will turn off, go on and on like this, depend on the interrupt function. So as you seen in the example code, right, there is something that I want to tell you about the ISR function, the function that will be performed whenever interrupt happen. You have to make it simple and short, right? The variable that we declare and use in this function should be declared as volatile. In this case, as I mentioned before, we declare interrupt on the setup part. In this case, we use attach interrupt on digital on pin number 2, which is external interrupt pin for Arduino Uno. And the function that we perform when interrupt happen is change state. And then the trigger mode is rising, right? So it means in this sentence, in this command, in this line, it means that whenever interrupt happen on the rising mode, the signal from low to high or from 0 to 1, the change state function will run. For the change state function detail, let me explain as following. For change state function that I used in the interrupt, this function will be activated whenever interrupt happened. Okay, let me explain this one. The state inside change state function, we have spin and CW. The spin means if it's true, the motor will run. If spin is false, motor will stop. CW, if it's true, it means it will rotate clockwise. If it's false, it means it will rotate counterclockwise. In the change state, when interrupt happen, let's start from this one. When interrupt happen, right, the spin variable will change, and the CW also will change. But CW will change only interrupt happen and spin variable have the value equal to. Only in this case, CW will change. And then interrupt happen again. This time the spin also change from false to true. But the CW will not change because the condition of the CW will change just only when spin is in the true condition only. And then from this state, interrupt happen again. At this time, the spin also change from true to false, and CW also change from false to true because the spin condition is true. And then interrupt happen again. The spin also change, but again, this time CW will not change, it will be the same. So in change state, right, it will change the variable spin every time interrupt is activated. But from variable CW, it will change when interrupt happened and when the spin variable have the value equal true. So it means CW will change the state from true to false, from false to true, or it means from counterclockwise to run counterclockwise just when the spin is equal to, or mean that just when the motor is running only. Okay, for the loop part, in this command, it will command the stepper motor to run, but in two conditions. The first condition, while spin equal to true, and while spin and CW equal to true. So in this part, it means when the motor, when the spin is true and when the counterclockwise is true, it will command stepper to run clockwise. this one. But in another case, when the spin is true and when the counterclockwise is false, it will command stepper motor to run counterclockwise continuously. So in the loop part, we provide just for two cases, run clockwise and run counterclockwise. Before I end this project, let me show you the demonstration of this project again. Enjoy.